Assalamu alaikum wa rahmatullahi wa barakatuhu. In the last video, we started the chapter 1, Real Numbers, where we tried to recall the different types of numbers like natural numbers, whole numbers, integers, rational numbers, and irrational numbers. We also learned about the types of decimal expansions of both rational and irrational numbers. In this video, we will define real numbers and start exercise 1.1. Here's the number line. The numbers 1, 2, 3, 4, 5 till infinity are set of natural numbers. If we include 0 also in this set, then the set becomes that of whole numbers. Here this is a set of whole numbers, and integers include positive, negative as well as 0. Rational numbers and irrational numbers can also be represented on real number line. This is the real number line. They lie in between the integers. In exercise 1.1, we will learn how to represent rational and irrational numbers on number line. Let us define the real numbers. The set of rational and irrational numbers together are called real numbers, as these numbers can be represented on number line. Pictorially, this rectangle represents real numbers in which there are two circles, irrational numbers and a vowel of rational numbers. Rational numbers also include integers, whole numbers, natural numbers. Natural numbers, whole numbers and integers are also rational numbers because all these numbers can be represented in the form of p by q. 0 by 1, 1 is equal to 1 by 1, 2 is equal to 2 by 1, 3 is equal to 3 by 1, and in the same way the negative integers too. Minus 1 by 1, minus 2 by 1 and so on. Let us start the exercise 1.1 in new mathematics textbook. The first question is, which of the following rational numbers are terminating and which are non-terminating repeating in their decimal form? In this question, we have to determine whether these rational numbers have a terminating decimal expansion or a non-terminating repeating decimal expansion. Let's start with the first Roman 2 by 5. We must divide 2 by 5 to know its decimal form. Here 2 is dividend and 5 is divisor. Let's divide 2 by 5. 5 zeros are 0. Remainder 2. Keep the decimal point as the division is finished. Put a 0 here. 5 fours are 20. And here the division finishes. So 2 by 5 is equal to 0.4. 2 by 5 is terminating in its decimal form. Let's see the second bit, 17 by 18. We need to divide 17 by 18. 18 zeros are 0. Remainder is 17. Keep the decimal point. Add a 0. 18 nines are 162. You can check in the rough work. 18 nines are 9 8 is 72. 9 ones are 9 plus 7 16. Remainder is 8. Put another 0. 18 fours. Let me continue it here. 18 fours are 72. Remainder is 8 again. Put 0. 18 fours 72. Again the remainder is 8. Put another 0. And 18 fours are 72 again. So in this way the division continues. So 17 by 18 is equal to 0.9444 and so on. The number 4 is being repeated here in the decimal expansion. So 0.94 bar. Bar is kept on 4. So 17 by 18 has non-terminating repeating decimal form. I am giving third and fifth bits as homework. Let's have a look at fourth bit, 7 by 40. Here 7 is dividend and 40 is the divisor. Let's continue with the division. 40 zeros is 0. Remainder is 7. Keep a decimal point. 41s are 40. Remainder is 30. So let's continue it here. Keep another 0. 47s are 280. The remainder is 20. Add another 0. 45s 200, and here the division finishes. And you can see 7 by 40 is equal to 0.175, which is terminating in its decimal form, as the division is stopping. Now let's have a look at the second question. Find any rational number between the pair of numbers given below. First bit, half and root 1. Here in each and every bit, you have to find a rational number between the given rational numbers. We need to find a rational number between half and root 1. Here, root 1 is equal to 1. So root 1 is equal to 1. We know 1 into 1 is equal to 1. So root over 1 is equal to root over 1 into 1, which is equal to 1. So we need to find rational number between half and 1. For this we need to follow the mean method. According to the mean method, if a and b are two rational numbers, then a plus b by 2, which is the mean of a and b, is a rational number between these two rational numbers. Here a is equal to half and b is equal to 1. We will follow the formula a plus b by 2 to find a rational number between half and 1. Applying the formula, half plus 1 by 2. We will take the LCM here 2. 2 1s are 2, 1 1s are 1, plus here denominator is 1, so 1 2s are 2, and here also 1 2s are 2. 1 plus 2 by 2 by 2, which is equal to 3 by 2 by 2. 3 by 2 by 2 is equal to 3 by 2 divided by 2, which is equal to 3 by 2 into the reciprocal of 2 by 1, which is 1 by 2, which is equal to 3 by 4. So this is the solution for the given problem. So 3 by 4 is the number lying between half and 1. Here second bit I am giving as homework, which is 3 whole 1 by 3 and 3 whole 2 by 3. Here you have to convert these mixed fractions into improper. 3 3s are 9 plus 1 10 by 3, and 3 3s are 9 plus 2 11 by 3. And apply the mean method and find out the rational number between these two rational numbers. See the third bit, which is root 4 by 9 and root 2. Let's solve that. Root 4 by 9 and root 2. Root 4 by 9 is equal to root over 2 into 2 by 3 into 3, which is equal to 2 by 3. And again it is equal to 0.666 and so on, which is equal to 0.6 bar. Root 2 is equal to, as we know, it is 1.414. So we can give the example of any decimal between 0.6 bar and 1.414. It may be terminating or non-terminating repeating. Like for example, 0.859, etc. Thank you. Jazakallah khaira.